In this video, we're given the value of electromotive force here. The value of electromotive force for some time t in between 0 to 30, we have 400. And for time t greater than 30, we have 0 as our electromotive force. Now, if this electromotive force is supplied to a series circuit where we have our resistance of 5 ohms and inductance of 50 Henry is in series. Now we are supposed to find our I of T, the current through the circuit for any time T, given our initial condition IO is equal to 0. Now we have our equation here, LdI dt plus Ri is equal to E of T. This is from the KVL, the Kirchhoff's voltage law. This means that the sum of the voltages across the 50 Henry inductor and across the 5 ohm resistor is just equal to the electromotive force supplied in the circuit. Now, this is the voltage across the 50 Henry inductor, LdI dt, and this is the voltage across the resistor 5 ohms. We have Ri with R being the resistance of the resistor is equal to the electromotive force as a function of T. Now for T in between 0 to 30, we have 50 di over dt plus 5I is equal to 400 because our electromotive force for these times in between 0 to 30 is 400. That's why we have 400 here. And 5 is our resistance, 5 ohms here. And 50 our inductance, 50 Henry. Now, dividing both sides of the equation by 1 over 50, cancel out. We have di over dt plus 5 over 50 is 1 over 10. I is equal to 400 over 50 is 8. Now we have a first order differential equation. Now this can be solved by finding the integrating factor. This is our integrating factor mu t, and we have e to the integral of 1 over 10 dt. 1 over 10 comes from here, our p of dv, coefficient of the variable I, is equal to, when this is integrated, constant out, and the integral of dt is just t. So we have this integrating factor, e to the t over 10 now. This has to be multiplied to our original differential equation. Multiply this to both sides of the equation, e to the t over 10 plus di times di over dt plus 1 over 10 I is equal to 8. This one here, this comes from here, 8 times e to the t over 10. Now, since this pattern here is just equal to the differential or the derivative of ie to the t over 10 with respect to t here, this can be verified if you actually take the derivative of this one. You can get di over dt times e to the t over 10 plus e to the t over 10 times I, and times the derivative of t over 10 with respect to t is 1 over 10 here. So this one actually can be rewritten as the derivative of I e to t to the 10 with respect to t is equal to 8 e to the t over 10. We have now to solve for I, we integrate both sides, and to remove the d over dt here, and this we have I e to the t over 10 left here in the left side of the equation is equal to integral of 8e to the t over 10 dt is equal to 80 e to the t over 10 plus c. Now, if you are still struggling integrating, then find formulas for the integrals. Here, we can divide e to the t over 10 to both sides of the equation. That's why we have I left in here is equal to 80 plus c e to the negative t over 10. Because if we divide it by e to the t over 10 here, cancel out, we have 80 here, and so we have c here, and bring the denominator to numerator and change the sign, negative t over 10. Now, using our initial condition I0 is equal to 0, we substitute 0 to our t because this is our current at time where t is equal to 0, meaning starting current. I0 is equal to 80 plus c e to the 0. This comes from here. We just substituted 0 in here, that's why this becomes e to the 0. And if this is equal to 0, because this is our initial condition from here, our c is 0 minus 80 or negative 80. That's why we have, for our t in between 0 to 30, we have r I of t as 80 minus 80 e to the negative t over 10. Now, let's go. What if our electromotive force now is 0 for time t greater than 30? We have our electromotive force as 0. That's why we have 0 here. This is just the same equation as the first page. Like here, we have here. But instead of 8, we have 0. We have I prime plus 1 over 10 I is equal to 0. Now, still we have a differential equation which can be solved by finding the integrating factor. The integrating factor is still the same. We have e to the t over 10 here. Then we multiply our integrating factor to both sides of our original equation. That's why we have e to the t over 10 times I prime plus 1 over 10 I is equal to 0, since 0 multiplied by any expression is still 0. Now, this form is just the same as this form. That's why we arrive at this form, because the derivative with respect to t of I e to the t over 10 is just this one, this expression here in the left side equation of left side expression in our equation. Now integrating to get rid of d over dt, we have I e to the t over 10 is equal to integral of 0 dt. Now the integral of 0 dt is just any constant, because the integral of 0 is constant because the derivative of any constant is just 0. That's just vice versa. Now we have our I is equal to c e to the negative t over 10 because we divide both sides of the equation by e to the t over 10. And our initial condition now is not I 0 because we started from t is equal to 30. Our initial condition now is I of 30. What is the value of I when t is equal to 30? Since we got the equation for our IT from the previous here. This is our equation for t in between 0 to 30, including 30. So our I30, we just substitute 30 here in our t, and then negative 30 over 10 is just negative 3. That's why we have here I of 30 is just 80 minus 80 e to the negative 3. This is just from our first equation we got from finding the value of I of t for time t in between 0 to 30. Now, this is our I30. 80 minus 80 e to the negative 3 is equal to c e to the negative 3. Now, this comes from here. If we substitute 30 here, we can arrive c e to the negative 30 over 10 is negative 3. That's why we have it here. So to solve for c, we just divide e to the negative 3 to both sides of the equation. That's why we have 80 e cubed minus 1, because 1 over e to the negative 3 bring the e to the negative 3 up and then changing the negative to positive. That's why we have e cubed, and e to the negative 3 over e to the negative 3 is just 1. That's why this is our value c. Now it is equal to 80 e cubed minus 1 e to the negative t over 10. This one comes from here, our c, and here, c. This is our c. And e to the negative t over 10 is this one. That's why for t is greater than 30, this is our equation. And that's it. That's all.